Namaskar my dear friends. So in the continuation of LTSpice simulation trainings, what we will do is we will do current division analysis in this session. So in this particular session what we will try to understand is, let us say we have a current source here and we have resistors, let's say R1, R2, R3. So like current across this R1, R2 and R3, what will be the difference, like IR1, IR2, IR3, like that. Okay. And what will be the power dissipation across each of the resistors, what will be the voltage at this node, and all these things we'll try to understand. So this is nothing but a current division analysis. So you also know the higher the resistor, lower the current in this, right? So you will understand, if value of resistance is high, the current flowing through that branch will be low. So this is very good, like our interesting part, how we can simulate our current analysis in LTSpice. So let us open LTSpice. What I have circuit is, I have like one current source, one resistor, one more resistors, and we have simulated this. So for your understanding, what I will do is I will just open a new window. Okay, it will be easy. Now let us quickly put a current source. So go to this component, and I am going to type current. Okay, so you can see there is a current source that has come. Now before clicking, I have to change the direction, so I have to rotate it, right? So what we will do is we'll place control R, then it is rotating, right? So I have pressed it, now it is done. So current source is kept. Now I'll just place two resistors. So resistor, let's say 1, 2, like that. I need one ground also for the circuit reference, so I'll place G, that is going to put a ground, right? Now to wire them up, I'll just take wire and quickly wire them up. Okay, so this is how you can quickly draw your circuit and put it. Good. Now to make it little bit like nominal values or practical values, I'll keep a current source of value of, let's say 3 milliampere. Okay, so 3 milliampere you can put like that. If you want, you can put milliamperes complete unit, otherwise 3m is enough. Okay, then let us say resistance I am going to put 1 kilo ohm, and R2 resistance I am going to put 2 kilo ohm. So you also know now that for 3 milliamperes, current across R2 will be 1 milliamp and current across R1 will be 2 milliamps, right? Twice of this. Now let's run that. So stop time we have to give, you can see transient analysis, we have to see how much time you want to run this circuit, right? So let us say I am going to run it for 1 millisecond and I am going to start saving data from 0, like beginning. So I want to start saving the data of simulated data from beginning itself, right? So it is done. So this is our circuit and we are going to find out what is my IR1, what is my IR2, right? So as you can see, to get the current across R1, go to this particular component. So you will see there is a probe going down. So it is going to give you a current across this resistor. So as you click, you will see there is 2 milliamperes current flowing through this. Correct? Similar to that, if you want to find out current across R2, go to this particular component and click left click, then you will see IR2 also. This is blue color, IR2, right? Now if you want to see what is the current of this 3 milliamperes, so this is your I of I1. So this is 2 I of I1 is red color, which is going to be 3 milliampere. I am not naming the nodes, so that anyway it is giving me I of R1, I of R2 and I of I1, right? Now let us say if you want to see voltage at this particular node, so what will be the voltage? Voltage is nothing but resistance into current. So 1 kilo ohm multiplied by 2 milliampere, right? So that will be 2 volt. So if you click here, this particular node will give you 2 volt. So you can see there is a 2 volt. V of N001, that is 2 volt. So if you want to name the node, you can put a label on this particular node. Let's say Vx. Okay. So I'm going to put Vx at this particular point. Now if you rerun it, okay, So my Vx is going to be, V of Vx is going to be 2 volt, right? Now let us try to understand how we can see the like power consumption across this resistor. So power will be what? V into I. So voltage across this 2 volt multiplied by current across this is 2 milliampere, right? So 2 into 2, that is 4 milliwatt. So what you have to do is across this component and then press alt, so the sign change, right? As you can see, press alt, there will be a sign change. Now you click left click, you will see power, right? So you can see a purple color, V of Vx multiplied by I of Rx, and that is going to give you the value. So I'll just double click this and it is going to give you 4 milliwatts. Only this value I am going to see. Or let's say current across R1 also I will see, that is 2 milliampere, and the power across this is 4 milliwatts. Similar to that, power across R2 will be this blue color, which is going to be 2 milliwatts, because the current is actually less than like 1 milliampere only. So 1 milliampere multiplied by 2 volt, that is 2 milliwatts. Understood? So good. If you want, you can change the value of current. Let's say 6 milliampere I want, or 6 am if you put, that will be also 6 milliampere, not a problem. And rerun that, then all these values will change, right? So you can see current across R1 has become 4 milliamps. So R1 current will be 4 milliamps, right? R2 current will be how much? You see, R2 current is 2 milliamps, right? Because current across R2 will be half of current across R1. Understood? Now let us quickly do one more thing. I am going to put like a resistor, one more resistor or two more resistor like this. So let us say I am going to put resistor one more here, and one more resistor I will just put in series, right? So let us quickly move this. This is for movement. So if you want to make a move here, then you place like this so that you can make a room here. And then if you want to delete, place like delete button, or press this cut button, okay? Then it will delete some of them, okay? Now let us say I want to move this R1, sorry, R4. So R4 has come here. Now let us quickly wire this circuit. Wiring up. Now if you see, there will be a difference now, right? Now what are the values that are missing? Let us directly run it. What happens? Let's see. Okay, so if I am going to run, it is telling can't find definition of model R. Okay, it means this, but if you press OK, it will give you error. So it is going to give you error for missing resistance value of R4. So R4 is not there, right? These are the like problems that you may always get. So you can see there is a report that is coming up, error on line 5, that is R3 value is not there, R4 value is not there. Okay, so let us quickly change these values to let's say 1 kilo ohm. I will put this also. You can put capital K or small k, not a problem, both will be same. Okay, let me put this one as 2 kilo ohm. So what will be that? 2 kilo ohm parallel 2 kilo ohm, that is 1 kilo ohm, and 1 kilo ohm plus 1 kilo ohm, that is going to be 2 kilo ohm. So let us say the current across this branch will be half of this IR1, that is very definite, right? So this will be 4 milliamps, this will be 2 milliamps definitely, that we know. Now let us simulate that. So I am going to see my current across like I1 is 6 milliamps. Now current across R1 will be 4 milliamps. You can see current across R1 is 4 milliamps, right? Now current across R4 will be, since it is opposite directions, it will say -2. So it is going to say -2 milliamps. Okay, I of R4 is -2, and this R4 will get like separated half because both of them are same values. So IR2 will also be 1 milliamps, and IR3 will also be 1 milliampere. So both are 1 milliampere, 1 milliampere. Correct? If you want to see what is the voltage at this point, so what will be the voltage? 2 kilo ohm multiplied by 1 2 kilo ohm multiplied by 1 milliampere, right? So that is 2 volt. So you can see this particular node is 2 volt, right? So if you want, I can just name this, label this net as Vy. So if you place here Vy, the value of Vy will be, let us say Vy. So Vy is 2 volt. So this is how you actually try to identify each and every nodes. Wherever you want to find the voltage or the current across a component, you can hover across this component, so your sign changes, and keep left click, it will give you the current across this particular component. Now if you want to find out power across this, press Alt to get the power across that. You can see there is a symbol change as soon as you press the Alt, right? So Alt, then power had changed, I mean symbol had changed, and it is giving you milliwatts, right? So you can see V of Vy, okay, the voltage at this point multiplied by current of R2. So current of R2, that is going to give you how much? Just more than 2 milliwatt. It is just around 2 milliwatt, okay. Good. So hope you have a good understanding about the current sources and different analysis of current. Now let us say quickly if we want to do a current source change. So I'll just right click this. Let's say I am going to take this particular circuit, okay, and if you want to change this 3 ampere to some other values, so let us say directly change this current, go to advanced, okay. Now let us make it to change pulse, okay. So I1, I2, it is asking, okay. So let us say I1 I want 0 and I2 I want, let us say 3 milliampere, okay. Delay I don't want anything. T rise, let's say I want 1 microsecond and 1 microsecond fall time. On time, let us say I want 5 millisecond, and T period total, let's say I want 10 millisecond. So time on is 5 and time off is also 5, so that the total time period is 10. Now let's run it. So as you can see, if you run this particular circuit, what will happen is the current source has changed, right? Pulse. Now if you run this, you won't be able to see any result. I will just show it to you. So see, the thing is you are not seeing, let's say I want to see the current value, this one. So current is not coming into pulse. Why? Because it has just run for 1 millisecond and I had put 5 millisecond as on time and 5 millisecond as off time. So if you want to see 3-4 pulses, what you should do? You should change the simulation time, okay? So if you change the simulation time, it will be easy for you to see the waveforms properly, right? So what you can do, go to simulate, edit simulation command, right? So go to simulate, edit simulation command, or you can go to settings and all, something like that if it is very new version or something, okay. And there I'm going to change it to, let's say 100 millisecond, okay. So that it can give me 10 pulses, or let us say I want to see 5 pulses, I will put 50 millisecond. And I will start saving the data to from 0 onwards, like beginning itself I want to save the data, so it will be 0. If you want to save the data from beginning, you have to put here 0. If you want to discard some of the data of the beginning, like let's say 10 millisecond you want to discard, then you can put here 10 millisecond, okay. So I will start the data from beginning. I have to stop the simulation time at 50 millisecond and press OK. You can see the transient response has changed to start saving data from 0 and up to 50 millisecond, okay. Now you simulated, let's say again we will do run. So you can see 5 pulses have come, 1 2 3 4 5, okay. So quickly you can see the current across I1 is 3 milliampere maximum and 0. For 5 millisecond it is on and for 5 millisecond it is off. Got it? The current across this will be twice of this. So this will be 2 milliampere. So you can see 2 milliampere is the current when current is there. When it is 0, it is 0. Similar to that, current across R2 will be half of that. So you can see 1 milliampere red ones, okay. So this is the beauty of like a simulator, that you can simulate easily, right? Now let us say what is the power across this. So power across this, if you want to find out, power will be 2 milliampere multiplied by 1 kilo ohm, voltage at this point. So let us say first we will find out voltage at this point. So probe this and click it. So you can see voltage at that point is 2 volt, okay. You can see 2 volt, right? Because the current across this was 2 milliamps multiplied by 1 kilo ohm. So V is equal to I into R. The current into resistance, that is going to be 2 volt. Now we will try to identify what is the power consumption across this resistor. So hover over this and then press Alt. So Alt, the sign is changed, and now you click it. So you can see power consumption across that particular IR1, like R1. So R1 is that, like this is purple color, it is not seen, so I'll just double click there. So power is 4 milliwatts. So 2 volt multiplied by current across this is 2 milliampere, right? So that is going to give you power of 4 milliwatts. So this is how you can analyze for different value of resistors, different values of your current sources. You want, you can have sinusoidal source also. If you want, you can have DC source also. Anything is there with you. If you want, you can directly just left click on this particular thing and go to settings and go and change your like pulses, like pulse waveform or sinusoidal waveform. You can see the like previous videos for having different pulses or different sources, and how to change their parameters for different parameters, right? So alright guys, thank you so much. If you do have any questions regarding this simulation of current analysis or voltage analysis or any kind of these questions, you please put down your questions in the comment box and we shall be able to answer you out. Thank you so much.